Have you ever thought about this? What if you could send a message, a thought, across an entire ocean in just an instant, with absolutely no wires? Well, today we're going to talk about the incredible invention that first made this possible, the radio. This is the story of how humanity literally learned to speak through empty space.
You know, for almost all of human history, sending a message without some kind of physical connection, that was basically magic. Communication needed a wire or a piece of paper, or at the very least, the air carrying your voice. But then, in the 19th century, a few brilliant minds started asking a wild question. Could we conquer the void itself?
So where does this story start? Well, you might be surprised. It doesn't begin in some workshop filled with crackling sparks. Nope, it begins in the quiet, abstract world of mathematics, with a single prediction that was about to change everything.
Okay, so picture this. It's 1864, and a physicist named James Clerk Maxwell is just doing math. He's working with equations. But his math starts to show him something incredible, something no one had seen before, that electricity and magnetism weren't two separate things. They were linked. And his calculations predicted that if you disturb an electric field, it would create this invisible wave, a wave that would travel at the speed of light. Now, he couldn't prove it with an experiment, but the math was undeniable.
It took a little while, more than 20 years actually. But in 1887, a German physicist named Heinrich Hertz finally proved Maxwell was right. In his lab, he created a spark that jumped across a gap. And then, the amazing part, he detected a second spark meters away with absolutely nothing connecting the two. Maxwell's invisible wave, it wasn't just a theory anymore. It was real.
All right, so these invisible waves exist. That's a huge discovery. But how do you get from a kind of strange lab experiment to a global communication system? Well, for that, you need a different kind of genius, an inventor who didn't just see the science, but saw the future.
And that inventor was Guglielmo Marconi. He had this revolutionary idea. He thought, if we can create these waves whenever we want, maybe we can use them to carry messages. All he had to do was turn a spark transmitter on and off in a specific pattern, and suddenly he could send dots and dashes, Morse code, right through the air.
And then came the big one. In 1901, Marconi did what many people thought was completely impossible. He sent a simple Morse code signal, it was just the letter S, all the way from England to Newfoundland, clear across the Atlantic Ocean. The world was absolutely stunned. For the first time ever, humanity could talk across continents instantly without any wires.
But like a lot of new technologies, this one had a big problem. Early radio was, well, it was noisy. It was full of static and interference. To really take over the world, radio needed to find a clearer voice.
So, the first radios used what we call amplitude modulation, or AM. Just think of a steady, constant radio wave, the carrier wave, like a perfectly smooth river. To send a sound, you just change the height of the waves on that river. The problem is, any other electrical noise, like from a lightning storm or even a car engine, also messes with the wave height, which makes the water all muddy and creates that static you hear on AM radio.
Then, in the 1930s, an engineer named Edwin Howard Armstrong had a total breakthrough. Going back to our river analogy, he thought, hey, what if we just ignore the height of the waves altogether, and instead we change how close together they are, their frequency? This was frequency modulation, or FM. And because most electrical noise mainly affects the wave's height, the FM signal stayed crystal clear. It was genius.
So you can see, the two technologies had really different strengths. FM's resistance to static made it perfect for broadcasting high-quality music. AM, on the other hand, it was noisier, but its signal could travel a lot farther, which made it great for long-distance talk radio. Armstrong's invention didn't just make radio better. It gave it a voice that was actually worthy of music.
So we've seen how radio came to be, but what's actually happening on a physics level? Let's take a quick look under the hood at the basic science that makes all of this work. You see, radio waves are just one part of this huge family of energy called the electromagnetic spectrum. And this spectrum includes pretty much everything, from the microwaves that heat your food to the very light your eyes are using to see right now. Radio waves are just the ones with the longest, laziest wavelengths in the family.
But how do you actually make these waves? And, more importantly, catch them? That's the job of the antenna. You can think of it like a magical translator. A transmitter's antenna turns electricity into radio waves, and a receiver's antenna does the exact opposite. It catches those waves and turns them right back into an electrical signal.
So all that amazing science comes together inside your radio.
Basically, the antenna grabs all the signals floating around in the air. When you turn that dial, you're telling the tuner to pick out just one of those signals. The radio then pulls out the original sound from that signal, powers it up, and sends it to the speaker. It's a pretty incredible process, and it all happens in the blink of an eye.
Now, I know this might all sound like ancient history, but the principles that were born in those early labs, they are the absolute bedrock of our modern connected world. In fact, you're probably using several different radios right this very second.
The technology itself has gone through this incredible transformation. I mean, early radios used these huge, fragile glass vacuum tubes. Then, the transistor was invented in 1947, which made them portable. By the 70s, we could fit an entire radio onto a single tiny chip. And today, your smartphone has multiple powerful radios on a chip for your Wi-Fi, your Bluetooth, GPS, and of course, your cell service.
When it comes right down to it, every single wireless technology we rely on today is a direct descendant of radio. Television, satellites, Bluetooth, and yes, the Wi-Fi that's connecting you to the internet right now, they all work because of those same fundamental principles discovered over a century ago.
The pioneers of radio really taught us something profound. The empty space that's all around us, it isn't empty at all. It is constantly humming with invisible messages, music, and data.
So the next time you connect to Wi-Fi, just take a second to remember that silent, invisible symphony of information that is passing right through you. It really makes you wonder, what other invisible messages are flying through the air all around us, carrying stories we just haven't learned how to hear yet?